Hello friends, now we are going to discuss chapter of similarity exercise 1.2. So in exercise practice at 1.2, first question they have given, identify in which figure ray PM is the what angle bisector of angle QPR. So they have given three diagrams. Out of those three diagrams, what we have to find, that ray PM is the angle bisector of angle QPR. So the first diagram is this one. See, the first diagram they have given in this way. Name is PQR, so this one is PQ and R, as they have given this point as M. This side they have given 3.5 and this one is 1.5. This one is 3 and 7. So what we will do now for this, to solve this one, we will write from figure if I will write QM divided by MR, that can be written as 3.5 divided by 1.5. So this is nothing but 35 divided by 50. This is nothing but 7 by 3, because we can divide 35 and 15 by 5. The 5 sevens and 5 threes out. So give me question number 1 to this. Similarly, if we go further, so we can take second ratio as of QP divided by PR. QP divided by PR. And this can be written as 7 divided by 3. So this is what equation. So very simple, if I will see that the ratio of the QM divided by MR, I'm starting from point Q. It is very important to understand when we are using angle bisector. So the starting point, the vertex point. So we are using vertex as a Q. So I'm starting from Q and I'm writing QM divided by MR. So QM divided by MR I have written, and that ratio is 3.5 divided by 1.5. This ratio is 3.5 divided by 1.5, and that can be what written as 7 by 3. Similarly, if I will take, see, first we have started from Q, so second ratio again we will start from Q only. So we will write QP divided by PR, and that ratio is 7 divided by 3. So if I will check equation 1 and 2, the right hand side are equal. So simply we can say that from 1 and 2, QM divided by MR, that is equal to QP divided by PR. So we can say that by this one, by the property of the angle bisector, and PM. Therefore, by property of the angle bisector, we can say that ray PM bisects angle QPR. In a similar manner, if we go for the second diagram, so what they have given in the second diagram, so this is the second diagram, so this. The second diagram they have given Q, this one, in this way. This one is R, P, Q. This is the bisector, and this one is M. They have given this one as a 6, 8, 7, and 10. Okay. Similarly, in this diagram, what we can do? In this diagram, again we can take a ratio of RM divided by MQ. So this can be written as 6 by 8. That is nothing but 3 by 4, because we can divide 6 and 8 by 2. So 2 3s and 2 4s. So this is the first equation. If I divide RP divided by PQ, so what we can write 7 upon 10. This is the second equation. From 1 and 2, the right hand sides are not equal. So simply we can say therefore what Rn divided by MQ is not equal to RP divided by PQ. Hence, PM, ray PM is not an angle bisector of angle QPR. So similar manner we can solve the third question also. So third diagram, what they have given, we will go for the third diagram, and what they have given in the third diagram. So they have given the diagram in this way. name as a QPR. So this one is Q, they have given, this one is P and this is R. So this one is working as a bisector and this point is representing M. What they have given as a value, this one is 4, this one is 3.6 and QP is represented by 9 and this one is 10. Okay. So this is the diagram, the third diagram of the question. So in this question, you can again apply the angle bisector property and you can write, if I will take Q as a vertex, so we can write QM divided by MR, so this becomes 3.6 divided by 4. Okay, if I will remove that decimal, so that becomes 36 divided by 40, because if I will multiply up and down by 10, so that becomes what? To remove this decimal, we will multiply up and down by 10, so that becomes 36 divided by 40, and both are what divisible by 4, so we can write 4 9s and 4 10s. So this is the first ratio. Okay, so we have started from Q only. So again, the next ratio we will start from Q. So we will write QP divided by PR, and this can be written as QP divided by PR. So that becomes 9 upon 10. So from 1 and 2, simply we can write from 1 and 2, from 1 and 2. We can write QM divided by MR, that is equal to QP divided by PR. These two things are equal, hence ray PM bisect angle QPR. So in this manner, very simple, you can solve what all three questions. Again I am repeating, see that again, quickly we will revise in 1 minute. If I want to identify in which figure ray PM, this ray is what bisecting angle P or not, that we want to what identify. To identify this, what we can do, very simple, we have studied about the angle bisector theorem. The angle bisector theorem is very simple. Angle bisector theorem is representing that this angle, if this angle is the bisector of angle P, for example in all three angles, P is the angle, and for P, PM is the what angle bisector. So this one is the angle bisector. That means what? If I will take P as a vertex, so opposite to this, that is QR. To side QR, this line is what? Dividing. So dividing some ratios to that line. So that line is what? That side is what? Divided by what? By PM in some ratios. So that ratios is always equal to the what? The remaining two sides ratios. So we have to keep in mind when we are writing angle bisector theorem, so we will start from the vertex. If I will take Q as a vertex, so if I am writing QM divided by MR, so we have to write the second ratio as a QP divided by PR. If I will take RP divided by QP, so we will get what? In different manner. So that become what? Wrong. So you have to keep in mind what? We will start both the ratio from the same point. And that point, if I am taking Q, so we can write QM divided by MR is equal to QP divided by PR. So we have taken QM divided by MR and that ratio is representing 7 by 3. And if I will take second ratio, that is QP divided by PR, and that become what? 7 by 3. So that means what? From 1 and 2, very simple, both the ratios are equal. And because of the angle bisector property, this line or this ray is what? Dividing this angle in two equal parts. So very simple, this is the what? Angle bisector theorem. Okay, thank you.